So continuation with the same chapter, energy. Today we are going to discuss with the remaining portion of the technical terms or the term associated with simple machines. That is the velocity ratio, mechanical advantage, work input, work output and efficiency. So in the previous class I discussed about the term machine. What is machine? The two types of machine, simple machine and a complex machine, and also work and energy. Okay, in order to do work, energy is needed. Okay, and also some terms related with the simple machines. That is fulcrum, effort, and load. These things I have explained you in the previous class. Now today we are going to discuss the remaining portion of the term associated with the simple machine. That is number one, velocity ratio. Now this velocity ratio, it is a ratio of the velocity of effort to the velocity of load. It is defined as, velocity ratio can be written as VR. Okay, so velocity ratio equals to velocity of effort, effort divided by velocity of load. Okay, and now this is the ratio. It is the ratio of the same physical quantity, that is the load and effort. Okay, so therefore it does not have unit. It is since it is a ratio, it does not have any unit. Unit means like meter, centimeter, okay, Newton, dyne, all the different physical quantity have a unit. But even the effort has got unit. The unit of effort will be is a Newton or kilogram force. Okay, and also the load will also be considered as a Newton. Okay, so that means load, effort, they have got some unit. But here the velocity ratio does not have unit, since it is a ratio of two similar physical quantity. So therefore velocity ratio is defined as the velocity of effort to the velocity of load. Now how to understand this definition? One example, consider example, a car jack. Okay, you have seen the car jack. This car jack I used to lift a car in order to replace the tire of the vehicle. If the vehicle gets punctured, you cannot keep on lifting the car for a long time unless and until the tire of the vehicle can be replaced. You get tired, so therefore you use a simple machine. And that simple machine is a car jack. And this car jack, though they are very much small in size in comparison to the vehicle is very huge, big, but the car jack is very small. And this car jack can lift a vehicle. Okay, it can lift a vehicle. So that means this car jack, though they are very small in size, but they do a large amount of work. And this large amount of work they will do by applying a small force on the car jack. So last time I told you that in all the machines, whether a simple machine or a complex machine, the machine cannot work by themselves. They cannot work by themselves. You have to apply the force on the machine, then only the machine will do the work. And the force which you apply on the machine, that is the effort. Okay, and the machine will do a work by lifting an object, that is the load. So now when we consider this car jack, okay, the car jack will put under the vehicle, under the car, near the tire. And what we will do is that now with the help of a rod, which you call it as a lever, with the help of a rod, okay, you just move that screw of the car jack, and slowly the car jack will move up. It will move up. So in order to make that car jack to move up, you will apply the force on the car jack. So when you apply the force on that jack, the jack will rise up. And when when the jack will rise up, then that jack will touch the car or the vehicle. Okay, and now that jack will lift a vehicle. So directly the jack will not be able to lift a vehicle. First of all, the jack has to move up. So when the jack will move up by applying a force, and that force will apply from your body, that is a muscular force you will apply. Okay, you will use a hand, okay, to make that car jack to lift up. So when that car jack will move up, in that case, what will happen? The machine will cover a distance, and that distance we call it as a distance covered by the effort. Distance covered by the effort. Okay, and to cover that distance, and already the distance has been covered. To cover the distance, some time is required. Some amount of time is needed. So let us consider is that the distance covered by effort. Let us say E is considered as effort. Now let us consider the distance traveled by effort is written as dE. Okay, distance covered by effort is dE, and the time taken to cover the distance is t. Now what I do is that now I find velocity. So in order to find speed or a velocity, to calculate speed, distance divided by time. So in mathematics we have read that to calculate speed, distance divided by time. To calculate distance, speed into time. To calculate time, distance divided by speed. So these are the three things which you have learned in class 5, even in class 4 also, about the time and distance formula. So following that, okay, now let the distance covered by effort will be dE, and the time taken to move the time taken to cover the distance is t. So let us find velocity. So velocity equals to distance traveled by load divided by distance traveled by effort divided by time. So this is the velocity. Okay, so therefore velocity, to calculate velocity, how we calculate velocity is distance divided by time. So the same thing is here. To calculate velocity, now the velocity of effort, to calculate velocity of effort, distance traveled by effort divided by time. Similarly, velocity of load, distance traveled by load divided by time. Okay, so again, now, so this, please follow this example properly. Okay, now the car jack, since the car jack is under the vehicle, now the car jack has to move up, so that the car jack has to lift a vehicle in order to replace a new tire in a vehicle. So the car jack will not work by itself. You fold your hand and stand. You keep the car jack under the vehicle and you just fold your hand and sit or stand. The car jack will not work. They will not lift the vehicle. First of all, you have to apply the force on the car jack, and that force which you apply in the car jack is the effort. Second point again is there. Now when the car jack will move up, in that case the distance is covered by a jack or a car jack, and that distance traveled by the car jack is considered as distance traveled by effort. That means by applying the effort on the car jack will move up, so that distance covered by the car jack is considered as distance traveled by effort. And to move that car jack, it requires some time. Okay, some time factor is required here, medium here. So let us consider the time taken to cover the distance by the car jack is t. Okay, so in that case, so velocity you can find it distance traveled by effort divided by time. So number one is the velocity of effort. The second one is the velocity of load. Now to find the velocity of load. Now what happens when the car jack will move up? Now the car jack will touch the vehicle. The car jack will come in, the car jack comes in contact with the vehicle. Once it comes in contact with the vehicle, now the car jack will start lifting the vehicle up. Okay, the car jack will lift the vehicle. So when the car jack will lift the vehicle, since vehicle is a load, so when the car jack comes in contact with the vehicle, now the car jack will lift a vehicle. When it lifts a vehicle, then in that case we consider distance traveled by load. So let us consider load, distance traveled by load is VL. Then to move that car up to a certain height, it again requires some time factor. So time is considered as T. So therefore, again, velocity of load can be considered as, you can calculate velocity of load as VL divided by T. So in that way, you can find velocity ratio. So therefore, when we consider velocity ratio, it is the ratio of the velocity of the effort to the velocity of load. Okay, so when you understand about this velocity ratio, just think over the example of a car jack. You are keeping the car jack under the vehicle. Okay, you have to replace the tire of the vehicle. Since the tire has been punctured, the vehicle will not be able to move. So you have to replace it. Then you put a car jack here. So once you put a car jack, you apply the effort, and that effort, you apply the force, and that force is the effort. And when you apply the effort, the car jack will move, and that distance covered by the car jack is the distance traveled by the effort. Okay, then again, the car jack will touch the vehicle, and now the car jack will lift a vehicle. When the vehicle will lift up, that vehicle is considered as a load, and the distance covered by the load is dl. Okay, once the vehicle will lift up with the help of the jack, the distance covered by the vehicle is dl, and it requires some time factor to move up. So therefore, the time is considered as t, and therefore, in order to calculate the velocity of load, distance traveled by load divided by time. So velocity of effort, distance traveled by effort divided by t. So therefore, in order to calculate velocity ratio, you have to consider the velocity of effort divided by velocity of load. So this way, you will find velocity ratio. So therefore, when we define velocity ratio is defined as the velocity of the effort to the velocity of load. Since it is a ratio of the two similar physical quantity, it does not have any unit. So this is the first point. Second one is the mechanical advantage, which will be written as MA. Okay, MA means it's the abbreviation. Okay, mechanical advantage. So mechanical advantage equals to load divided by effort. Mechanical advantage. So when we define mechanical advantage is defined as the ratio of the load to the effort. It is the ratio of the load to the effort. So that means this mechanical advantage also does not have any unit, since it is a ratio of two similar physical quantities. So ratio means load divided by effort is the fraction. So fraction can be written in ratio, or ratio can be written in fraction. Example, suppose 1:2 is here. This is the ratio. 1:2 you can written as 1/2. So ratio can be written in a fraction, or the fraction can be written in a ratio. So therefore, since load and effort, these are written in a fraction, so it is a ratio, since it can be written in a ratio. So the next point is the definition of mechanical advantage. Mechanical advantage is defined as the ratio of the load to the effort. Since it is a ratio of the two similar physical quantity, therefore it does not have any unit. Okay, and the next point is the work input. Work input means the work done on the machine. Work done on the machine is known as the work input, or the energy supplied to the machine. Work done input means work input or input, simply input. When we define this work input, it is the energy supplied to the machine, or the work done on the machine. Work done on the machine we call it as a work input. So this example is also the same. Okay, the same as that of taking a jack and the vehicle. Okay, now work input means the work done on the machine. In order to make the machine to work, first of all we will apply a force on the machine. So that force which is applied on the machine, that is the work input. Okay, so in order to lift the vehicle, first of all we will apply the force on the jack. Okay, and that force when you put on the jack, that is the work input. Other one is the work output. Work output means the work done by the machine. The work done by the machine to do some useful work. Work done by the machine to do some useful work. Now the next point is work done by the machine. Now what work is done by the machine now? Now the machine will lift a heavy load. It lifts a vehicle. Before that, the machine is just moving up, and when the machine moves up, you know that is the distance covered by the machine. Okay, and in that case we can find the velocity ratio here. Then again in the work output, when the machine will go up and it touches the vehicle, now the machine will raise a vehicle. So that means when it raises a vehicle, now that in that case we say that work done by the machine, or the work done by the machine in order to do some useful work. Some useful work is done by the machine. What useful work is done by the machine? There is, consider an example. You can be able to replace the tire of a vehicle. Okay, you can replace a tire of a vehicle by lifting a vehicle. And who will lift the vehicle? The machine will lift the vehicle. That is a car jack. And this car jack is a simple machine. Okay, so that is about the work output. So work input is the work, the work done on the machine, and work output is work done by the machine. Work done on the machine, work done by the machine. See the difference there. Okay, work done on the machine means the machine has to do work. Work done by the machine will, now the machine will lift up the vehicle in order to do some useful. That is the work output. The next one is the efficiency. Now this the word efficiency means capability, ability. Okay. Now efficiency is defined, and efficiency is always calculated in percentage. It is always calculated in percentage, 10%, 20%, 30%. Okay. So how to calculate efficiency is that work efficiency is defined as the ratio of the work done by the machine to the work done on the machine. Okay, that means work efficiency can be calculated as work done by the machine. Work done by the machine means that is work output divided by work input. Okay, work done by the machine, efficiency defined as the work done by the machine to the work done on the machine, multiplied by, that is 100. So in order to calculate in percentage, you have to multiply by 100. So when we define efficiency simply you can write efficiency is defined as the work done by the machine to the work done on the machine. Work done by the machine to the work done on the machine is known as the efficiency. Now why I am writing this output at the numerator and input at the denominator? Input also I can write it at the numerator, and this I can replace it. Okay, now what is there is a reason behind it. Now the work output is always more than the work input. Work output is always greater than work input. So always the smaller number should be written at the denominator and the larger number should be written on the numerator in order to divide. Okay, so this is the reason. So the work output means the work done by the machine. Work done by the machine is more. The machine will do a large amount of work, but the force which is applied on the machine is less. Work done in the machine, that is the work input, is always less. We have to apply a less amount of work. That is why we call it as a machine, isn't it? So machine, by applying a small force, the machine can do a large amount of work. What force you have to apply? Effort you have to apply. Unless and until if you don't apply the effort or force, the machine themselves will never work. So little bit of force you have to apply it, and that force which is applied on the machine we call it as a work input, and that work, the value of work input is always less in comparison to work output. So that is why it is written as work output at the numerator and the work input at the denominator, and we have to multiply by 100 since efficiency is calculated in percentage. So these are the terms related when we discuss about the simple machine in higher classes, still you go in detail, you study in detail, more detail about all this efficiency, work output, work input. Okay. But these are the basic things we have to remember, that when we learn or when we study about the term simple machines, we have to know about the term fulcrum, the effort, the load, velocity ratio, mechanical advantage, work input, work output, and efficiency. So these are the terms which are related with the machine. So in the next class, I'll explain you about the idle machine and the practical machine and about the